Welcome to Creative World. In this video, we will solve chapter 3 exercise problem number 3.14. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.14. Use nodal analysis to find the value of voltage V0 in given below figure. This is the circuit diagram of given problem. Inside this network we have to find value of voltage across this 2 kilo ohm resistance labeled as V0, and we have to use nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from that network. So using this equation, we can find out that figure. In this equation, n represents the number of nodes exist in the network. In this network there are 3 number of nodes, so 3 minus 1 will be equal to 2. So maximum 2 number of node voltage equations can be retrieved from this network. In next step we have to label all unknown non-reference node voltage. This node voltage is labeled as V1 and voltage across this 2 kilo ohm resistance is taken as this node voltage, because this voltage is appearing on this node with respect of this reference or ground node. So whatever the value of voltage will be on this node, same voltage will be appearing across this 2 kilo ohm resistance as well. In next step we have to assume all unknown branch currents along with their directions. Now we will apply one by one Kirchoff's current law on these two nodes to find their respective node voltage equations. We will start from here. On this node, two currents are entering, 2 mA and I1, while only one current is leaving, I2. Entering currents are taken with positive sign, while leaving current is taken with negative sign. In next step, we have to replace these two currents with their respective equations. Current I1 will be equal to 12 volt minus V1 divided by 2 kilo ohm. This resistance is connected between a node voltage and voltage source, so voltage across this resistance will be equal to the difference of these two voltage levels, and current through this resistance will be equal to the difference of these two voltage levels divided by the value of resistance. The direction of current I1 is from voltage source to node 1, which is indicating that the value of voltage source is on higher potential than node voltage V1. That's why node voltage V1 is subtracted from 12 volt. So the difference of these two voltage levels will be equal to 12 volt minus V1 divided by the value of resistance will be equal to I1. Similarly, current I2 will be equal to V1 minus V0 divided by 4 kilo ohm. Now in order to omit all denominator values, we will multiply this equation on both sides with 4 kilo ohm. Product of 4 kilo ohm and 2 kilo ohm in denominator will cancel out with each other, only 2 will left, and that 2 will multiply with 12 volt minus V1. Here product of 2 mA and 4 kilo ohm will result 8 volt. Here product of 4 kilo ohm and 4 kilo ohm in denominator will cancel out with each other, only V1 minus V0 will left. Open these brackets. The equation will become 24 volt minus 2V1 plus 8 volt minus V1 plus V0 equal to 0. Now add 8 volt and 24 volt together and sum up all values having same variables together. The equation will become 32 volt minus 3V1 plus V0 equal to 0. Place this constant value on the other hand side of equal. The equation will become minus 3V1 plus V0 equal to minus 32 volt. We cannot further solve this equation, so leave it for now and label it as equation A. It is the first node voltage equation of this network. Now apply Kirchhoff's current law on this node. On this node only one current is entering and one current is leaving. Entering current is taken with positive sign and leaving current is taken with negative sign. Next step, we have to replace these two currents with their respective equations. Current I2, as we have calculated in previous step, is equal to V1 minus V0 divided by 4 kilo ohm, while current I3 is equal to V0 divided by 2 kilo ohm. Now multiply this equation on both sides with 4 kilo ohm. The equation will become V1 minus V0 minus 2V0. Open these brackets and add values having same variables together. The equation will become V1 minus 3V0 equal to 0. This is the second node voltage equation of this network. Up to this point, we have retrieved two node voltage equations of this network. Now we will try to solve these equations in order to find out the value of voltage V0. For that purpose, we will take equation A as it is and will multiply equation B with 3. The equation will become 3V1 minus 9V0 equal to 0. Now add these two resulting equations together. Minus 3V1 and plus 3V1 will cancel out with each other. Sum of minus 9V0 and V0 will become minus 8V0. On the other hand side of equal, minus 32 volt will left. Now divide on both sides with minus 8 to calculate the value of voltage V0, that will become 4 volt. So the value of voltage V0 in this network across this 2 kilo ohm resistance with this polarity is equal to 4 volt. This was all about exercise problem number 3.14. Thank you. See you again in next video.